let's talk about the discriminant. So the discriminant, denoted by this symbol here, which is delta, of a function f, tells us the number of x-axis intercepts of a function f of x, where f of x is in the form ax squared plus bx plus c, where a does not equal to 0. So in other words, our parabolas or our quadratic functions. So the discriminant of the function f is found by taking b squared, subtracting 4 multiplied by a multiplied by c. And these parameters just come out of our quadratic formula. So for example, if we have f of x is equal to 2x squared plus 3x plus 4, then the discriminant of this function is equal to 3 squared, subtract 4 multiplied by 2 multiplied by 4, which is equal to 9, subtract 16 multiplied by 2, which is 32. Okay, so how does this negative 23, which is the discriminant for function f over here, how does that tell us about the number of x-intercepts? Well, it's pretty straightforward. So if the discriminant of f is greater than 0, that tells us that f of x has 2 solutions, or 2 x-intercepts, or 2 roots. They all mean the same thing. If the discriminant is equal to 0, that tells us that we have exactly 1 solution. And if the discriminant is less than 0, that tells us that we have 0 solutions. So let's just make sure that we all know what this looks like when we talk about a quadratic function having a solution or a root or an x-axis intercept. So what I'll do is I'll just sketch out just the x-axis, because I don't know too much about this function f over here, right? I don't really know much about it other than it's a upright parabola and its discriminant value is negative 23, which is less than 0. So that tells us there'll be 0 solutions. In other words, it will hit the x-axis 0 times. And since it's upright, it has to be above the x-axis, right? So we know here that the discriminant of this quadratic here is less than 0. Similarly, for a quadratic down here, because it also hits the x-axis 0 times. If we have a single solution, in other words, the discriminant equals 0, what we'll have is the turning point is going to touch the x-axis. Same if we have an upright parabola. Discriminant equals 0. And 2 solutions, you've probably figured it out, is just going to cross the axis twice. Discriminant is greater than 0. Right, so now we understand what information the discriminant tells us about a quadratic function, and we know how to use it, and we've seen some visual examples. But let's actually try to understand where this discriminant comes from, and in order to do that, let's derive it for ourselves. So what I'll do is I'll write out the quadratic function, sorry, the quadratic formula. Quadratic formula. So remember, the quadratic formula tells us the x-intercepts locations for a function f of x, where f of x is in the form ax squared plus bx plus c, with a not being 0, right? So the exact same definition that we have above, it tells us the x-axis intercepts for our parabolas. And the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So what I'll do now is I'll rewrite the quadratic formula in a slightly different form, just rearranged with a little bit of simple algebra, so we can analyze it pretty easily. So quadratic formula tells us x is negative b divided by 2a plus the square root b squared minus 4ac divided by 2a. And the other solution is negative b divided by 2a, subtract the square root of b squared minus 4ac divided by 2a. So let's compare these two solutions that we have. So let's analyze the first term in our solutions. There's two things that we can tell. First of all, between the two solutions, this is the same mathematical expression, right? So this minus b on 2a, that's common between both. That's it. The second thing we can say is it's a number. And okay, that might seem a little bit silly to say, but let's break that down. Imagine if a was equal to 0. Let's just give b a random, actually no, let's keep b as a parameter. So what we'll have is this first term will be negative b divided by 2 times 0, which is 0. And this here is undefined. Right, so that would not be a number in this case. But remember that we've said, because we're dealing with quadratics, a is not 0. So this case doesn't ever occur. So we can say that this b divided minus b on 2a is the same between both solutions, and it is a number. Okay, they're both important points. Okay, so now let's analyze the second term in the quadratic formula, and let's ignore the plus and the minus for now. So the first thing that we can say, again, is that, well, these two are the same expression, and so this number is going to be the same, right, in our positive and our negative solutions. Well, I did just say number, right, but can we be sure that this second term is always a number? The answer to that is no. And the reason is because we have a square root, right? So let me just write this out here. If we have the square root of some number alpha, the question is this defined? In other words, is it a number? Well, if alpha is greater than 0, then yes. And in fact, we'll have 2 solutions to this expression, right? Because imagine that we're taking the square root of 4. The answers to that are positive 2 and negative 2. If alpha is equal to 0, yes, because the square root of 0 evaluates to 0. But in this case, we only have 1 solution to that expression. And finally, if alpha is less than 0, well, no, we can't evaluate this. This is not defined because, well, we can't take the square root of a negative number when we're talking about the real numbers, okay? So in this case, there's 0 solutions to this expression, the square root of alpha, where alpha is negative. Okay, so now let's take what we just talked about and apply it to the whole solutions of the quadratic formula. Okay, so let's bring it over here. Let's rewrite the quadratic formula out. X is equal to negative b divided by 2a plus the square root of b squared minus 4ac divided by 2a. And the second solution is minus b on 2a subtract square root of b squared minus 4ac divided by 2a. Okay. So let's imagine that the argument of the square root, first of all, is negative. So b squared minus 4ac is less than 0. By the way, this is just here so that I can scroll all the way to the right so that the page expands. All right, so in this case, the rightmost term, so the right term is undefined. Right, and so what we're going to have is a number in both cases plus something which is undefined, right? And well, you can't have a number plus something which is not a number and result in a number, right? In other words, there's no solution to this equation, right? So 0 solutions. All right, that's the straightforward case. Now let's think about b squared minus 4ac equals 0. So what we're going to have, as we established, is a number on both sides, and we're going to add the square root of 0 divided by 2a, and we're going to subtract the square root of 0 divided by 2a. Well, 0 divided by anything, both cases, is 0. So what we have is the same number, right? Negative b on 2a plus nothing. And the other solution is that same number minus nothing. And so what we end up with is one solution. And that is because, let's just write it out formally, minus b on 2a plus 0 is equal to minus b on 2a minus 0, which is, exactly what we have here. So now let's cover the third and final case, where we have b squared minus 4ac is greater than 0. And what I'm going to do is, let's come up with some number, let's call it beta, and beta is equal to the square root of alpha. Okay, so plus and minus beta. So in other words, if you took beta squared, that would equal alpha. If you took negative beta squared, that would also equal alpha. Okay, so I'm just doing like a substitution. So what we're going to have is x is equal to negative b divided by 2a plus, and then, right, we've got the square root of alpha, which is positive and negative beta. So plus minus beta on 2a. And we also have that the other solution is negative b on 2a, subtract plus minus beta divided by 2a. Well, if you wrote this all out, what you'll end up with is actually 4 equations. So I might as well do that for the sake of just completeness. So let's keep the positive terms, I'd say. So we've got x is negative b on 2a plus negative beta on 2a. And the fourth solution is negative b on 2a minus negative beta divided by 2a. What you'll see is that this solution here doubles up with this one, and this solution here doubles up with this one, right? Because you've got plus plus, minus minus, they're going to both result in just adding the two terms. And you've got minus plus and plus minus, they're both going to result in subtracting the second term from the first term. A lot of people think that this plus minus, right, this plus minus arises from this square root. I used to think that too, but it actually doesn't, right? So we're going to end up with an additional plus minus, right? And so we kind of have 4 solutions where 2 of them repeat. Anyway, sorry for going off topic, but as I said, we can reduce this to just being first solution and second solution. So let's just pick one of those. Well, they're the same thing, so let's pick one of each. So x is negative b on 2a plus beta on 2a, and x is also equal to negative beta on 2a minus beta on 2a. So what we're going to have is number, right? Same on both solutions, plus another number. And this, remember, this is definitely not 0 because we've established that b squared minus 4ac is greater than 0. So if you take any number and you add something which is not 0, and you take that same number and you subtract that same number which is not 0, these two things here for sure are going to be different. And that is the reason why when b squared minus 4ac is greater than 0, you will have 2 solutions to your quadratic formula. So now let's just do some quick summary of all of this information, nice and neat. So when we have b squared minus 4ac is less than 0, we have 0 solutions. When we have b squared minus 4ac is equal to 0, we have 1 solution. And when we have b squared minus 4ac is greater than 0, we're going to have two distinct solutions. And this here is exactly what we learned about at the start. So now all we have to do is say that the discriminant is equal to b squared minus 4ac. We'll give this repeating expression a name and a symbol. And here we have the discriminant. So hopefully you understand in this video how we can use the discriminant to tell us about the number of x-intercepts that a parabola has. And we've also learned how we can derive the discriminant for ourselves, right? Because it's better to understand how things work rather than just knowing that they do work.